Generate Define.XML step-by-step guide. Introduction. Here is a step-by-step process to create Define.XML for any clinical trial study. It is a practical and production-ready workflow which you can follow from planning to delivery. This includes what to collect, how to organize metadata, tools, validation steps, and common pitfalls. Step 1. Confirm requirements and version. Confirm which Define.XML version your submission requires, commonly CDISC Define.XML 2 version or 2.1 version. Check sponsors, authority expectations, file names, and coding any extra documentation. Agree scope, SDTM only, ADAM only, or both, and any non-CDISC datasets to be described. So the first step is to confirm the requirements and version. Any clinical trial study that you're working on, especially for any therapeutic area study, the common fundamental is to check the scope of the agreement, whether we need to present only SDTM datasets, or we need to present only ADAM datasets, or we need to present both datasets, or whether it's related to CDISC or non-CDISC datasets in the SDTM version. Even the version is also very important. You also need to have the expectations from the sponsor and the authority person, and ensure that whatever expectations that you get from the sponsor and authority, it should be in writing, and there should not be any verbal communication. Even if there is a verbal communication, please ensure to have write it in the minutes of meeting and confirm that with the sponsor, and then go ahead while working in the Define.XML. That is the diplomatic way for working in professional culture. Step 2. Inventory datasets and files. List all datasets, CDISC domains, ADAM datasets, supplemental, special purpose datasets. For each dataset record, file name, dataset label, type, whether it's SDTM, ADAM or other format, XPT, CSV file, or dataset level keys, for example, unique subject ID plus sequence, record counts. Collect list of external files you will reference, for example, CRF, which is the annotated page, shells, code list, standard PDFs. Now, external files, it could be also your laboratory vendors, files that you get, the external files. So any external file that you're importing, it should be incorporated in this Define.XML. Step 3. Build or gather metadata sources. Gather authoritative metadata sources to drive Define.XML. Domain specifications, dataset shells, SDTM, ADAM specs, or sponsor templates. Annotated CRF for variable origins, CRF page mapping and form names, control terminology lists, which is CDISC, CT, or sponsor list, derivation specifications, for example, analysis derivations, programming specs, ADAM, ADSL derivations, etc. Programming dataset headers, labels, types, lengths used in final XPTs. Prefer a single metadata repository, that is CSV, Excel, shared database, or SAS datasets as the canonical source. Step 4. Define the file and study level metadata. Collect and record study identifiers, study name, study OID, study ID. Define document metadata. Define.XML version. Creation date and time, responsible party, author or contact. Software used to generate Define.XML, tool name and version. File list, dataset names, file types, dataset ID, dataset label, SAS dataset name, CRF pages, mapping if applicable. Step 5. Create dataset level metadata. For each dataset domain, collect dataset ID, dataset name, for example, DM, AE, AD, AE, label, description, purpose, for example, findings versus events versus special purpose, what are the keys, whether it's primary and secondary, observation class for SDTM, where clauses if a dataset is a filtered extraction, links to CRF pages or annotated CRF. Step 6. Create variable level metadata. For each variable in every dataset, capture variable name exact as in dataset, label, short descriptive label, data type, text, numeric character, length, significant digits if numeric precision, role, for example, identifier, topic, timing, qualifier, origin, whether it's CRF, derived, assigned, computed, external, use consistent origin terms, contrology terminology, CD, code list name or source, and value level mappings if applicable, code list references, code list ID/name, comment, derivation text, clear programming level expression or reference to SAP step, notes about missing value encoding if non-standard. Step 7. Value level metadata and code list. Prepare code list, ID, name, data type, code, decode, source, CDIS, sponsor. For variables using control terminology, map every code used in datasets to the code list or indicate per submission data. For free text or partially coded variables, document any translations or normalization rules used. Step 8. Document derivations and algorithms. For each derived variable, provide a clear derivation statement, formula or pseudocode. For example, AENDTC equal to AENDY plus AESTDY minus 1 or derived from CRF page X item Y. Reference the SAP programming spec or macros that implement the derivation. If complicated, include a short code snippet or algorithm description. For Adam, document analysis flags variable origins, for example, source, DS, EX, DM, and any imputation rules. Step 9. Collect supplemental documents and links. Attach or link annotated CRF, ACRF, usually referenced from Define.XML, data conversion specifications and mapping tables, SAP extract sections describing analysis variables, any external vocabularies, MEDRA version, WHO drug version, include file names and where to find them in submission package. Step 10. Generate the Define.XML. Options: metadata repository, generator tool or programmatic build. Using tools, for example, metadata repo plus Define.XML generator, commercial or in-house. Pinnacle 21's utilities, SaaS programs, proc metadata based, open CDIS tool chains or custom XLST scripting. Programmatic approach. Generate XML programmatically from authoritative metadata, CSV, Excel, SAS, ensuring tags conform to Define.XML schema and the chosen version 2 and 2.1. Ensure XML encoding is UTF-8 and conforms to the schema. Steps 11. Validate and QC. Schema validation. Validate generated XML against CDIS Define.XML XSD for your version. Content validation. Use tools such as Pinnacle 21 Community or Enterprise or sponsor validators to check clinical consistency, dataset label mismatches, missing descriptions, code list mismatches. Cross-check every dataset referenced in Define.XML exists in the submission and vice versa. Every variable listed appears in the dataset and variable attributes, type, length, label match the exact XPT CSV. All code list reference exist and include codes used. Human review. Have a reviewer read derivation statements, again programming specs and ACRF. Fix issues and rerun validation until clean. Step 12. Produce human readable outputs. Generate a PDF or HTML summary for reviewers. Some regulators like a human readable define or include it in reviewer's guide. Consider creating a Define.XML rendered from XML and Define.XML both included in the submission DM package. Step 13. Version control and provenance. Name files with a version, date, timestamp, and maintain a revision history in the defined document. Defined document revision history. Document who created, approved the Define.XML responsible party elements. Archive source metadata, master CSV, SAS dataset so you can reproduce the XML. Step 14. Final packaging and delivery. Include the Define.XML, the dataset XPTs, CSVs, code list if separate, annotated CRF and Define.XML if created in the submission package. For example, SDTM Adam DM package. Provide a short README for reviewers that explains location of files and non-standard conventions. Deliverable checklist. Define.XML created using correct Define.XML version and encoding. All datasets reference are present, names and labels match. Every variable for label, type, origin, role and derivation if derived. All code lists are defined and include used codes. Annotated CRF included and linked. Schema validated and passed Pinnacle 21 sponsor validator. Revision history and responsible party filled. Define.XML or human readable export created if required. Files versioned and archived. Now these are the checklist where you need to check each and every parameter, whether you are presenting the names, labels, data sets, role, origin, then the ACRF, whatever files that you are uploading in Define.XML, each and everything that needs to be cross-checked whether the links are working properly. For example, say you are clicking on dm.xpt file, so that data set should be opened. So all the links that you have mentioned in the Define.XML, everything should work and all the links should open the relevant files. So these are the checklists that you need to keep in mind while generating the Define.XML, and this is the step-by-step guide. Many thanks for watching my video and happy learning. Please like, share, subscribe, leave a feedback comment. Many thanks for your support and having great connection.